All right. Hi, everyone. Happy Wednesday. Thank you so much for attending today's webinar, Wildfire Readiness in the Age of AI, Statewide Data Strategies for Preparedness, Mitigation, and Recovery. And that will be with CAL FIRE and Ecopia today. My name is Emily Reitz. I'm the Chief Technology Officer at the National States Geographic Information Council, or NSGIC for short. If you're unfamiliar with NSGIC, we exist to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. And if you'd like more information on how to get involved with us, please visit our website, www.nsgic.org. And just a couple housekeeping reminders real quick. Everyone's been muted upon entrance, and there will be time at the end of the presentation for Q&A. So if you think of a question, feel free to put it in the chat when you think of it. I'll be keeping track of those. And they'll be read aloud and answered at the end of the presentation. And if we've got time, we'll also utilize the raise hand function and have people come off mute and ask their questions as well. And like I said earlier, this will be recorded. It is being recorded. And the recording will be made available to all registrants afterwards. So just keep an eye out for an email with that. All right, presenters, take it away. Thank you.
All right, thanks, Emily. I'll just quickly introduce myself here for everyone that doesn't know me. I'm a senior associate for Ecopia AI. I'm particularly working with U.S. state governments on the land cover initiatives that they are undertaking. And through that work, we are now working with CAL FIRE, with Mark, and we're excited to talk a little bit about today about the data that we delivered in CAL FIRE for CAL FIRE across California and how they're putting it to good use. And with that, I'll let Mark introduce himself next.
Thank you, Thomas. My name's Mark Rosenberg, and I'm a research data manager with the California Department of Forestry and Fire Protection. I have over 30 years of experience in GIS analysis, remote sensing, and forest inventory. In my current role, I work on wildfire preparedness issues for CAL FIRE's Office of the State Fire Marshal, where I support initiatives for fire-safe clearance around homes and power lines. We track fuels reduction projects, and we work on home hardening initiatives for the public. I'll give you a little infomercial on CAL FIRE. If you're not really familiar with us, we are a state department. We're the largest fire agency in the state. Our mission is to serve and safeguard the people and protect the property of the state of California. Our vision is to lead a dedicated, diverse workforce and inclusive workforce while maximizing partners to create a safer and more resilient California. We value integrity, service, community, and diversity. And delivering that mission means providing fire protection on over 31 million acres of forest and rangelands in California. We have local government contracts, mutual aid agreements, and we are an all-hazard agency. We also provide resource management and regulation on private forest lands and for commercial timberlands. We have urban forestry programs, environmental protection programs, and forest assessments and other state forestry type programs in our resource management division. I work for the Office of the State Fire Marshal, where we work on fire-safe engineering and code development, fire prevention and planning and mitigation efforts, land use planning, and fire safety review for county and city general plans. And we also work on utility fire prevention. This year, CAL FIRE responded to over 7,000 wildland fires, almost 3,000 structure fires, and over 340,000 medical calls. And it's really exciting time to be working with CAL FIRE over the last 7 or 8 years. Really has ramped up our location-based data and technology use within the department. We're really leveraging a lot more GIS and dashboards and mobile apps in our data-driven approach to decision-making. And building footprints and land cover data are commonly used data sets in our GIS. And we've been working with Ecopia to provide updated building footprint data and land cover data to improve our decision-making and drive some of our key programs. And some of the programs that I support that use building footprint data include our fire safe clearance, defensible space inspection programs, our post-fire damage inspection, and our fire hazard severity zone mapping. I think I'll turn it over here for Thomas to talk a little bit about Ecopia.
Excellent. Thanks, Mark. Yeah, I know many of you are familiar with Ecopia, so this slide's more geared towards those of you who aren't. But we started in 2013 to 2015 out of PhD research. And that PhD research was focused on how do you train a machine to interpret building footprints from imagery as a human would. And that imagery that we were initially working with was satellite imagery. And you see the 2013 to 2015, and you might think that we're a relatively young company, which you're not wrong, we are. But if you look at it in relation to AI, machine learning as a whole, or even cloud computing, that really wasn't around or wasn't mainstream in 2013 to 2015. No one was talking about that until 2022. So we were really at the forefront of this industry, which is why we've grown to where we are today and we're able to produce the scale and accuracy that we're doing. Our first big project happened just over a year later after we commercialized in 2015. So the project was in 2016, where we mapped out every single building in Australia for their federal government. So that was 16 million buildings across 3 million square miles, and that was done in only 6 months. A year later, we then mapped out every single building footprint in the United States, and that's still maintained to this day. So initially in 2017, 2018, that was 169 million buildings across 3 million square miles in 6 months. So roughly the same landmass, roughly the same time frame, but we 10x that building footprint output. So it goes to show how fast in those early years the scalability of these algorithms was growing. And now that was the 2017, 2018 figure. I believe the 2025 most recent figure of our nationwide building footprint map is 185 million building footprints. And that's mostly used for the insurance industry. I'll get a bit into that later, but obviously the focus of today is going to be the work on California. We then transitioned to land cover mapping and also transportation asset infrastructure mapping. So that's more where you see us do what you see us doing today. So different types of features, so impervious surfaces, what type of impervious surface, driveway, sidewalk, road, and then different types of vegetation, water bodies, tree canopy, shrubs, grass, those sorts of elements. And then we've recently done some very large projects. One of them I always like to share is the one we did in partnership with the Bill and Melinda Gates Foundation. That was mapping out all of sub-Saharan Africa, so 51 countries. And we did that for their building footprints and the road network. And that was used for polio eradication and then COVID vaccine distribution. So really identifying where those more rural communities and underserved communities are in Africa so that they would have an adequate access to these life-saving vaccines. And so really beforehand, it was just a problem of actually locating where these people were with this vaccine distribution effort. And so just having this critical data made it a lot more efficient and effective. And then following 2022 to present, we've really been working on building out a high resolution nationwide land cover map in the United States. So really trying to scale up the algorithms, really trying to partner with all different imagery providers so that we can do these large scale data sets and then really democratize access to this pretty critical data so that could be used for a multitude of different reasons, from items like Cal Fire is using it right now to different floodplain management and whatnot. And then, yeah, there's a lot of different use cases, which we might be able to cover as well in a couple slides. And if we go to the next slide here, you will actually be able to see some of those visualizations of what those building footprint projects actually look like. So in the top left, you have Australia. You can see all the building footprints located on the East Coast primarily, United States as well. It's a cool visualization to see the population density in the east side versus the west side. Italy is another nationwide building footprint map that we created. I think that was in 2023. And then you have all of sub-Saharan Africa on the far right. And as we move on here to the next slide, you can see all of the different verticals that we're working in, or I guess I should say the four main verticals. So you have civil engineering, telecommunications, government, obviously, and then insurance. Insurance is where we're doing that building footprint, maintaining that nationwide building footprint map year over year. And that's done with the Maxar satellite image. And that's really identifying whether or not a building footprint is in a flood zone or not. And then government, we're working on all different levels from municipal, state, and federal, primarily geared towards just land cover initiatives, and then also if your transportation initiatives. And as we move forward, when we're discussing building footprints, I'll have Mark go to the next slide as well. And then we're talking about the problem. So why Ecopia is building footprints. And as I discuss the problem here on why data sets like this are so important, we come to the fact that the total cost of climate disasters in the United States since 1980 has surpassed $2 trillion. And these events aren't isolated. They're intensifying and their impacts are compounding. Flooding alone accounts for roughly $8 billion each year in the US, and that causes not just the widespread property damage, but also loss of life and massive environmental disruption, which can't be quantified. Then you have the problem with wildfires, which are obviously a central focus for CAL FIRE, and that costed roughly $4.4 billion in suppression efforts alone in just 2021. And beyond the economic toll, they destroy ecosystems and threaten communities across the United States. And then you have another example with extreme heat, which is quietly the deadliest of all hazards deadliest of all weather-related hazards with over 1,700 heat-related deaths reported in 2022, with the most severe effects in urban areas and among vulnerable populations. So there's an equity issue behind it where it's often the poorest communities with higher impervious surface contents and low levels of tree canopy, which exacerbates these urban heat islands. And then as we're looking closer at wildfires, the trend is pretty clear. So wildfires are becoming larger and more frequent. On U.S. Forest Service land alone, the number of fires exceeding 1,000 acres has risen pretty sharply since the 1970s, as you can see in this graph, with both the scale and intensity of them increasing over time. And these events don't just destroy forests, but they also impact air quality, water systems, and local economies. Now, the image on the right was a day I'm sure a lot of you remember from a couple years back in New York City, where the wildfires in Quebec carried smoke south towards the entire northeastern portion of the United States, which darkened the skies and significantly degraded the air quality. I believe this day in New York actually had the worst air quality of any city in the world. And what that shows is that even if you don't live in an area that is impacted by wildfires, it doesn't mean you aren't affected by it. It's something that affects us all, even if indirectly, and that's why it's so important to discuss these topics. And for CAL FIRE, the increasing fires translates to enormous operational strain. And so this is where geospatial data really becomes essential to allow them to visualize conditions at scale and then model risk dynamically, which Mark's going to get more into in a few slides here. And now this is a study that we did in Sarasota County following Hurricane Ian. And I know in hurricanes, the wind causes a lot of damage, but the flooding also always wreaks havoc, or almost always wreaks havoc. And in Sarasota County, across the whole county, not just the flood zones, which is the stat you see here, Ecopia had 225,000 building footprints, compared to some open sources, OSM with 130,000 building footprints, and Microsoft had 198,000 building footprints. And then diving a bit deeper, you can actually see the difference of the building footprints within the FEMA designated flood zones on your screen. So there you have Ecopia with 41,000, OSM with 27,000, and Microsoft with 36,000. And to further quantify that, that's 134 million square feet of Ecopia building footprint data versus 122 million square feet of Microsoft. And so there's a few different reasons for these large discrepancies against the Ecopia data versus the open source data. And the first is that What Ecopia is doing is we're ensuring we are using the most recent and up-to-date imagery available. So any new builds will be picked up. Well, you have the open source data can often be using input sources that can be 10 plus years old. And so the input data sources, they're also frequently inconsistent and unreliable. So scraping together different inputs, different imagery vintages, and then using that and then piecing those together. Now, the second thing is that when we're picking up these building footprints, we have a lot of great imagery partners. So for CAL FIRE, we use Hexagon, and we actually used the raw imagery, so the raw multi-view imagery. And so we're usually getting an angle if there's some sort of occlusion between a tree canopy. So you're getting a more accurate result from a top-down perspective where you might not be seeing that building footprint if there's heavy tree canopy coverage. So normally with this approach, we'll be getting some sort of angle, and then the AI will be able to assume where that building footprint is meeting. And then also because we're using so many different vintages, we've been maintaining these data sets in the past. If we've had some sort of building footprint there, then it's almost a confirmation process. So we know there's probably something here because we've seen it in the past, and then we're really just looking for signs that that building's still there. And then the third is that we have a rigorous QC process to ensure that we're minimizing false positives and false negatives, while also ensuring the true accuracy of the building footprint polygon is sufficient. And now the next slide here, we did a comparison of our building footprints versus Microsoft's in Orange County, California. And what we found was a pretty significant difference of approximately 55,000 building footprints, which shows that the open source data is missing approximately 20%. And it wasn't just the sheer number, but as you see in the GIF, there's also a notable difference in the actual polygons drawn. And really, don't get me wrong, open source data, it's great when you're looking to do a high level analysis and gain an understanding of the environment. But when it comes to actual life-saving endeavors, having the most accurate and current data to rely on is pretty essential. And that's when we move, that comes to our 3D land cover initiative. If I get Mark to go to the next slide here, which is what we're really trying to build out across the entire nation. And these are the standard features that we're working on building out. And as you see, we're using that stereo aerial imagery. So that also allows us to build out these building footprints in 3D. And this is what I consider the 95% solution. So there are more layers that we can do, but these layers meet the standard needs of most of the people that we work with. And then we get to the how, like how are we developing these data sets and technology? And at a high level, we'll take the imagery, then it goes to our machine learning. And then we have a QC process, as I briefly mentioned earlier. And that QC process has 3 stages. So we randomly sample a large portion of it. And that when our manual QC team is going through that, they fix any errors. They're validating that it meets the 95% accuracy spec. And then any errors that they find will then get re-inputted into the model and then reapplied. And then over time, it continues to grow and the accuracy increases. Another way we're doing it is our AI is automatically generating a raster probability map. So it's flagging areas where there is a higher probability of a false positive or a false negative. And those get picked up and sent to our manual QC team, where then they go fix, and then that gets re-inputted back into the models. Then we also allow our client to QC the data themselves, because having that local expertise is very important. And then they'll go create any points, then we would take that, reapply it, and then time and time again, it will continue to evolve. And just through these data sets, as you can see, working over 10 years with this continuative, iterative approach, it's really the reason why we achieve these high accuracy, very large scale data sets that we're doing today. And when you look at data creation as a whole, if we go to the next slide here, we see a comparison between manual digitization methodologies and automated software methodologies. And with manual digitization, it's great. You get a very accurate product. You get that 95% accuracy, which is needed for data-driven decision-making. But the problems are it's very tedious work to do. It takes a lot of time. And so it can become expensive and hard to scale. Then you have your automated software where you have those advantages of automation. So it's affordable, it's scalable, but it's just not very accurate. And you're going to have to spend a lot of time with post QC to get an accuracy that you need if you're even able to achieve that. And that's where Ecopia really comes into the mix, where I like to say we're the best of both worlds. So we get that high accuracy due to the semi-automated approach. We have the advantages of the automation, but we also get the accuracy of the manual digitization. And then I'll move on to the deliverables and show you what we actually are doing with CAL FIRE. So as we go to the next slide, you'll see the general overview and a quick image of what we were producing. So it was a 16-layer land cover solution from bare lands, buildings, driveways, forests, parking, pavements, so different impervious surfaces and different vegetation categories. And this was done across all of California's fire hazard severity zones, which covered just over 30% of the state, or of around 32 million acres. And then we extracted the building footprints, which was over 9 million building footprints in this area. And then we took the land cover data and attributed the building footprints with some pretty critical information. So such as distance to the nearest building, distance to the nearest water body, including swimming pool, distance to the clearest road, distance to the nearest tree canopy or vegetation source. And then we also used our own proprietary methods to geocode all of these building footprints. So we took zoning data, parcel data, and address data, and then attributed those building footprints further. And this slide here, you can kind of see a bit more of what those geocoded building footprints look like. So you have your street addresses, you have all your zoning attribution. Each footprint has a unique ID. There's a group ID for multiple buildings on the same parcel, and then there's the unique property ID. It's attributed with things like building square footage as well, and the imagery capture date, and then you have the land cover attribution as well. And a little bit into of how our geocoding actually works here is our geocoding accuracy is around 97, 98%. And historically, insurers have been using either street level geocoders or parcel central geocoders with accuracies around 55%. And when I say accuracy, I mean the centroid is placed on top of the correct building 97, 98% of the time. And the reason why that's so important is because if you're using a street level geocoder and the flood zone is between where that centroid and the building footprint is. In the same case with the parcel centroid geocode, that won't be properly appraised as in a flood zone or not. And this is why 7 of the top 10 US property and casualty insurers use our geocoding engine to get that actual building-based geocoder. So it's the most accurate and reliable source. Because you might think that these are all fringe cases where that flood zone might be between this geocoder and the building footprint. But if you look at a nationwide scale, we're talking tens of millions of dollars of misappraised value on or in those flood zones. And here in the middle image, you can actually see a great example of that. So this is a community under one parcel. On the right, you see that one red centroid there. But if you take the building-based geocoder on the far right, you'll see each unique building footprint has their own centroid with their own unique address. So that's really the advantage that you're getting there. And as we move on to the actual land cover attribution, these are all the different attribution that we provide from the land cover. So the size of the building footprint, distance to tree canopy, distance to the nearest building, distance to water source, including pool, and then the distance to the nearest road or driveway. And Mark, I'll share my screen quickly as well to actually pull up. I just have to send a request. I think Emily might have to approve that to actually pull up the data that we produced. Now I'll just give it a time. My Zoom usually takes around 15 to 30 seconds before it lets me share my screen.
while we're waiting, I will just add that the geocoding and getting the location on the building is really important in some of our programs. We work in a lot of rural areas, and getting you to the parcel doesn't always get you to the structure.
Yes, perfect. Thanks. That was a good transition. I trust you can also see my screen now.
Yes.
Perfect. Appreciate that. So this is the actual data that we built out in California. And I was just looking through this earlier. This is actually in Paradise, California, which had some, I think, a bad wildfire in around 2018. There's actually a new Apple TV movie with Matthew McConaughey about these fires. So it's a good movie, kept me on the edge of my seat if anyone's looking for a movie recommendation. But here, I'll just zoom in. I have the opacity down so you can see the actual underlying imagery on top of the building footprints. You have your address centroids, you have your building footprints, bare land, your driveways, forests, grass, parking, pavements, railways, roads, sidewalks, sports grounds, swimming pool, and water. So those were the layers that we delivered. And then you also have your tree canopy layer. The difference between tree canopy and forest is that the tree canopy will overlap with the impervious, while the forest will cut at the impervious surface layer. Now, when I actually click on an address, you will see all of the address information here. So you have your address, your footprint ID, group ID, address level, your zip, state, a whole bunch of attribution there. And then when I click on the building footprint, you can see some of the other attributions, the footprint ID. Then we took zoning information and attributed that against the building footprint. So you have a residential, the subcategory, 2 families, the zoning code. Then you have other information like distance to nearest building, distance to the closest water source, including pool. So that would be this pool right here. Distance to nearest road, which also includes driveways. So it's accessible via driveway or roads. That's why it's being picked up as 0. You have the square footage, and then you have the imagery vintage date here. And then over a large scale, this isn't the entire area that we mapped. This is just a portion. You can actually see where this is in California. So just, I think it's around the northeast portion of California. And now with that, I'll let Mark share his screen as well. And then I think the next step is you to actually talk about the use cases.
Can you see my screen?
Yep, perfect.
Great.
We can see
Right.
the presenter view. So if you
Oh yeah.
swap them. I almost didn't notice. I was like, oh yeah, looks good.
Yeah, I didn't notice right away as well.
Thank you.
Mm-hmm.
See if it's going to let me do this. This one. Just start it again this way. Can you see this
Yeah, perfect.
presentation view?
Yep.
Okay. Let me just go back, catch us up. All right. Thank you, Thomas. Yeah, the use cases, and that was a good use case. I appreciated seeing the fire example because we've had a lot of large fires over the last decade, impacting lots of structures, and getting updated building footprints for those areas was important. And some of the open source products, we didn't see them being updated, and we were cobbling them together from different sources. And so we really wanted to enter into an agreement with Ecopia to update a large portion of our state. And so we did. We've been under contract with Ecopia for over a year now, and they delivered data based on 2024. And we're going to do an update again this year. And some of the program areas that we're looking to use that data in include our fire hazard severity zone mapping, our defensible space program, and our damage inspection program. And with the fire marshal, as I mentioned, I work more and support community resiliency projects. And these include things like our Defensible Space program, where we do inspections for fire safe clearance around homes and power lines out in the wildland areas. And our pre-fire program, where we prioritize and implement fuels reduction projects. We have a land use planning program that works with local government to identify fire safety issues, like single road in and out, or road width standards. And so they work with those communities to improve the safety elements in their general plans. And we have home hardening and wildland urban interface building code standards and initiatives for the public. And tying together a lot of those programs are our fire hazard severity zones. And I did a lot of the geospatial analysis to create these maps. This is, I think, our second round of maps. We did them in 2006 through 11, and we recently updated state responsibility areas, and that was in 2023. And this year we completed our recommendations for local responsibility areas. And one of the, so for our fire hazard severity zones, there are sort of 3 levels that we mapped things to, moderate, high, and very high. And these maps are required by law. And they help guide where building code standards for new construction need to meet fire safety code and use more fire safe materials. It also identifies places where you need to disclose the fire hazard for the sale of real estate. And working with local government in areas with high fire hazard severity zones, our land use planners work on road access and widths and other infrastructure issues as they work those into the county and city general plans. And these are important issues. The data that we're getting from Ecopia is at a very fine scale. And I think it's going to help us in our delineation of fire hazard severity zones on this next round. And because the fine scale really improves how we can delineate urban versus wildland areas. And that's one of the first big divisions of the landscape when we're doing fire hazard severity zoning. And when you're doing that, you're really looking at within the forest and rangelands, the driver is really flame length and burn probability that drives that hazard. But in urban areas where we don't have very good models for understanding urban conflagration and how fire spreads, we rely more on proximity to wildland and the brand production and that could happen and be received at that urban location. So it's more of a proximate threat from vegetation and embers that help us do zones in the urban areas. But we do okay. 68% of the structure lost over this 7-year period was very correlated with our very high fire hazard severity zones, and also 14% in the high zones. So we're doing okay, I think. But one of those other programs that relies on defensible space, is moving on to the second use case here, is our defensible space inspection program. And I talked about us moving into sort of a more use of geospatial technologies and tools. And this is one of the first big areas where we really had a breakthrough with our executive and decision makers. And this kind of came around after several large fire years and subsequent Blue Ribbon Commission findings, where they wanted to set a goal of 250,000 parcels inspected every year. That would get us about through all of the parcels in state responsibility areas in about 3 years. But this was originally, it was a paper process used to conduct, used at each fire station. And we would go around to the homes in those areas and look for fire safe clearance standards. But then we were able to convert it to a digital process and leveraging dashboard technology. Our executives love this. This is also available to the public, so they can see that we're meeting our inspection targets set by the legislature. And a little commercial about defensible space. If you live in a wildland area, and we have a lot of that in California, you need defensible space around your house to help protect you from wildfire. And what does that mean? That means you're removing flammable materials and vegetation around your structure, especially in the 0 to 5, the 5 to 30, and 30 to 100 foot range. We have different standards that are aimed at those different zones. And in that first 0 to 5 feet, we're recommending hardscaping and non-combustible fencing and no vegetation or flammable items within that first 5 feet. Away from there, in that next 30 feet, from 5 to 30 feet, you want to remove dead or dying vegetation. You want to keep your grass mowed, and you want some space between your trees and removing brush from under them and doing some limbing. And so these are some of the things that we inspect for when you're in a very high fire hazard severity zone or in the wildland areas. And with good reason. Our damage inspection data show that greater than 90% chance of completely destroying your house if it gets ignited by a wildfire. Which takes me on to our third use case here. Post-fire damage inspection. And this is an image and map from January of 2025. We had several large fires in Los Angeles. The Palisades and Eaton fire burned over 16,000 structures and claimed the lives of 29 people. And since 2017, we've had 4 of the most destructive wildfires in California history, including the Camp Fire that Thomas pointed out. And you can see, here's a 3D visualization of the Palisades fire, and in orange, you can see where the fire burned, and you can see the extruded building footprints there for visualization, but knowing where those are helps us identify and inspect the damage for those structures and be able to report that back out to residents who are curious. And it's important to keep them out of the fire zone during these critical periods because it's not safe. There's power lines that are down, they're still burning embers. You get these hidden holes, where septic tanks might have burned out. Here's another image, California, you can see wildland that's right next to structures. And this is the Kenneth fire, burned around the same time as the Eaton and Palisades fire. And it's about 1,000 acres. And here's a little visualization of it coming in very close to those homes. We didn't lose any of those homes in this fire, I believe. But you can see the kind of challenge that we have. And so, using building footprints for damage and guiding our damage inspection crews and identifying the burn status of structures inside the perimeters is an important function. And, structure susceptibility, I talked a little bit about the lack of good models in built environments. And so one of the things that's emerging in some of the research from Headwaters and from UC Berkeley and others, Michael Gollner, is looking at the susceptibility of the parcel. It's not just tree limbs and vegetation, but it's also proximity to other structures that can greatly influence and contribute to damage in urban areas. And we're recognizing these are urban conflagrations that are quite a bit different spread and heat profiles from in vegetation and wildland areas. So that's some of the area. Those are some of the areas where research is going on. We also have a aerial rapid assessment effort. We have remote sensing intel group, and they can look at, they fly imagery post-fire, and it's utilized for assessment, aerial structure assessment, they call it, and allows us to give a quick count for the media and FEMA and others about the nature of the burn structure and how many. But then we always follow up with our field inspectors, and having the accurate building footprints really helps when you're looking at a post-fire image or when you're going out to see whether the structure survived. And you can use the QR code there to get into our public data viewer. So just to bring it home here, we really are enjoying working with Ecopia to deliver fine-scale building footprint data. These urban conflagrations, as I mentioned, are becoming more common and destructive. And CAL FIRE is really leveraging location-based technologies in a data-driven approach to decision-making. And land cover data and building footprints are commonly used data sets in CAL FIRE's GIS. We're really leveraging those in our defensible space inspections, post-fire damage assessments, and soon fire hazard severity zone mapping. And to help with researchers looking at improving their models, this data will be really important. And we can't go visit every structure every year, but having some information about the separation, building separation, tree limbs and distance to vegetation might help us as we're evaluating the hazard at the parcel level. So with that, I will say thank you and leave some contact information up there, and happy to answer any questions. Emily, back to you.
All right. Thanks, everyone. If you have any questions at this point, oh, it's so fun to see a little clap reacts. If you have any questions, feel free to raise your hand, as I don't see anything in the chat.
I don't know how to raise my hand.
That's
there's
fine.
I was going to say, this is Allie Reiner. Do you think any next steps with this type of data and technology could be looking at retrofitting existing structures? Like, could you get down to roof material or number of vents or roof complexity or any other details that would tell you about home ignition potential?
Well, I can talk about that from the technology standpoint, and it's a very difficult thing to do at scale when you get to that level, and it's not something that's in the capabilities at this time. But obviously, that's where the technology is going. Whether that's a 5-year scale or a 10-year scale, I'm not sure. But really, as the imagery gets better too, that's helping, especially where 1-inch oblique imagery is becoming more readily available as those cameras begin to improve. That's going to help. But yeah, there's a lot of complication when you actually are trying to pick that up, because there's a lot of ambiguity from that actual pixel. And so hopefully one day we will be able to do something like that, but it's just not really something that we can do right now, or at least in the next couple of years.
Yeah, and I guess I'll say that CAL FIRE is addressing, taking a different strategy with, we've got our defensible space inspection programs, and we can identify those features. And we've got grant programs aimed at home hardening, especially for those areas where you're in a very high fire hazard severity zone. We want to help folks retrofit the existing building stock, because we recognize that 80% of our buildings, 90% of our buildings were built before our 2008 building code standards started to apply. So we have some tools, self-assessment tools, and there's also a lot of legislative initiative driving us towards looking at the existing building code, building stock, and how to retrofit it. We're not using AI yet, but a lot of those data points that we collect might actually be useful for some of that.
All right. Thank you. Wolfgang, go ahead.
Hi, this is a question for Mark. My name is Wolfgang. I work for the Arizona Department of Forestry and Fire Management. I'm the GIS manager there. And I was just wondering, Mark, if may I contact you offline about your CAL FIRE's product, the fire hazard severity zones?
Absolutely, sure.
We are, of course, behind compared to California, but we also need to go in the same kind of management space as you do.
Yeah, I'd be happy to talk with you and share anything I can. And we've got a lot of experts. We've got a fire scientist that would love to, I'm sure, engage with you.
Thank you very much.
Oh, yeah, we've got some questions in the chat now. First of which is, where can we get all the data?
So I will say this data, unfortunately, isn't publicly accessible right now. The licensing towards the data, it's perpetual towards CAL FIRE. Now, if you're looking for data along the coast, we do have a great program in partnership with NOAA, which is the CCAP program, the Coastal Change Analysis Program, which isn't as refined as the CAL FIRE data, but it's still an incredible data set, and it covers around 1.5 million square miles of the United States with impervious surfaces, vegetation, and water at a 1 meter raster level. And I would be able to connect you with those resources, but you should be able to find it if you just Google NOAA, OCM, CCAP data, and then you can look at the boundary for that yourself.
All right. Next we have, looks like a rhetorical question. Somebody pondering if the data and aerial imagery could be used for firefighters on the ground, printed run sheets if it's not already. So
Interesting.
looks like just tossing an idea out there. So thanks for that,
Appreciate
Greg.
that. Always
Yeah.
looking for ways to get tools into the hands of our first responders.
Yeah, we've got another question. What is the accuracy of the defensible space use case, the HIZs, and the separation distance between tree canopies within FireWise/WUI standards?
So I'm not sure how to describe accuracy of the defensible space use case, but understanding that we have lots of folks working out in the field and being able to get them to the structure quickly is really important. The FireWise communities, certainly we are looking at different ways to improve on that program. And this kind of building footprint data might help them understand risk a little better and keep track of their structures in the community. But I think really as we start to look at hazards at the parcel level, having building footprints all the way down to 100 square feet buildings is going to help some of the modeling. As I mentioned, the structure separation distance and distance to vegetation are really important metrics. So we can't get to every structure. And so having some of those metrics to get an idea about susceptibility or parcel level hazard is really important. I hope I answered your question.
Thank you. All right. Jose says, great presentation. How often is the data set updated/maintained? How often do you visit the sites, every year or more?
Well, this is a contract, so we updated it last year for our fire hazard severity zones, and we're going to update it again this year. And then, we would need a new contract, and I'll, probably pursue that as we start to leverage these tools and data in our modeling efforts.
Cool. And then looks like the, yeah,
Yes,
for the
and
data,
Brianna's
Brianna
linked on
shared
the
the
next
link.
one. So
Mhm.
you'd be able to find the link to the open NOAA data for the CCAP program through Brianna's message there in the Zoom chat.
Awesome. That looks like all the questions in the chat. Does anyone else have anything?
Just want to thank you, Emily, for having us come speak today to your audience and to the audience for listening. It's always fun to come tell folks what we're doing.
Mm-hmm. Oh, we got one more in the chat. Any plans to leverage spectroscopy? That one took me a second. To leverage spectroscopy with these data sets. Spectral analysis could mitigate things like resolution for material determinations.
I'll leave that for Thomas. I do understand, hyperspectral imagery is pretty good at identifying different types of materials, and roofs are important. I don't know whether we're going to get something like that out of the optical imagery that we're using.
Yeah, right now, and the immediate focus of the extractions we're doing is we're just using the 3 bands RGB imagery. And I think those are the plans for the near future when we're extracting these data sets. Can I say that definitively over the next 10 years? No, but right now it's our focus, and for the time being, we're going to stick with that.
Oh, sounds good. Yeah, thank you both so much for presenting today. Very much appreciated, and it was wonderful.
Great. Well, thank you, everybody. Guess we'll get a few minutes back of our day.
Indeed. Thanks so
Excellent.
much.
Thanks everyone for coming out. And if you have any questions, again, you can follow up with myself or Mark.
Sounds good.